All right, so let's take a look at this one here. We have the two sources, and this is drawn a little bit more precise than my freehand drawing there. We have source 1, source 2. They have equal wavelengths, and we can look at where we have constructive and destructive interference. So point P is two wavelengths from S1. So if you look at that, here's S1 right here, right? And if we go, one wavelength, then two wavelengths, that's how far point P is from there, right? And then from source 2, it's three wavelengths. So here's one wavelength to this crest, another wavelength to this crest, and then another wavelength to this crest. And so because they're both a full wavelength, a multiple of a full wavelength away, we're going to get constructive interference because they're both in phase. They're both crests at that point. You can see the blue line crossing. You can see the green line crossing there. They're both crests. So the way that you'll see this on your data booklet, it'll say constructive interference path difference is equal to an integer of lambda. So in this case, 3 lambda. So n is 3 for source 2, and then for S1, it's n is 2, representing 2 wavelengths away. And so anytime we have that, when it's a multiple, we could have even another source, and let's say it's like 6 wavelengths away. As long as it's an equal or a full wavelength, you're going to have constructive interference. How about point X? If let's say we had way out here, right? Well, if we look at it, how far away is it from S1? Well, we can go here. There's one wavelength, two wavelengths, three wavelengths away. And then how about for S2? You go 1, 2, 3, 4. It's 4 wavelengths, right? So 3 wavelengths there, 4 wavelengths there. The path difference between them, if we subtract them, 4 wavelengths minus 3 wavelengths, yeah, the path difference is exactly 1 wavelength. So therefore, there is constructive interference, right? We subtract the two difference, how far away they are, and we get constructive interference. How about point R? Well, in this case here from S1, point R, we go here 1 wavelength, 2 wavelengths, 2.5, right? How about from source 2? Well, from source 2, 1 wavelength, 2 wavelengths away. So if we subtract those, and we look at actually just, visually we can do that first. S2, right? We have 1 wavelength here. We have another wavelength that's a crest right here at a point R. But for S1, right, you have 1 wavelength. You have 2 wavelengths, 2.5. This is actually a trough. So you have a trough with a crest. You have destructive interference. So if we subtract them, our path difference is n plus 1/2 lambda. And if we do that, we have 2.5 wavelengths minus 2 wavelengths. We end up getting 1/2 of a wavelength. And so therefore, 1/2 a wavelength is a path difference, which means destructive interference. So you have a crest and a trough together. How about point Y? So I'm going to let you try that one. Go ahead and figure out how far away is from source 1, how far away from source 2, and give that a try. So go ahead and pause the clip and give that a try, and when you're ready, you can check, or you can hit play to continue. Okay. So it's 3 wavelengths from S2. If we look at that, so 1 wavelength, 2 wavelengths, 3 wavelengths, and then from source 1, it's 1 wavelength, 2 wavelengths, 3 wavelengths, 3.5 wavelengths from source 2. So it's a 1/2 wavelength difference between them. Therefore, we have destructive interference. If they were, let's say one was 4 and one was 4.5 or whatever, you would have the same thing where you have the destructive interference. All right, so in this one, we have two identical waves, or identical waves leaving two sources, arriving at a point P. Point P is 12 meters from the first source and 16.5 meters from the second source. The sources both have wavelengths of 3 meters, and we want to find out what happens at point P. So let's see if you can use what we just talked about there to figure out what would happen in terms of constructive or destructive interference. So go ahead and pause the clip and give this one a try. And when you're ready to check, you can hit play to continue. All right, so source 1's 12 meters away, source 2 16.5 meters away. Here's point P. Constructive interference is path difference, equals n lambda, and then destructive interference would be n plus 1/2 lambda. So what we can do is find the path difference. What is the path difference? Well, that wave would have to travel 12. The other one would have to travel 16.5. So the path difference is 4.5 meters. And yeah, if we look at it, and we know the wavelength is 3, so we can place that in there, this would give us destructive interference, because if the wavelength is 3 and we end up getting 4.5, the only way that this is going to work is if we use this equation where the path difference is, an integer plus 1/2. So yeah, so this is going to be destructive interference at that spot. So what's kind of interesting in this picture, you can see these two waves, or these two sources. In this case, there are two wavelengths away from each other, so here to here, and then from here to here. So they're two wavelengths away from each other. If you notice with these lines that are made here, it shows where we have destructive and constructive interference. And so the red lines are where they're integer multiples, and so therefore constructive interference. And then the black lines represent where there's destructive interference. So let's just follow one of these lines. Let's do the one that's straight right here. So if you think about it, for this one, right? Let's say the source comes out of here. It's going to go one wavelength. Then it's going to go another wavelength, and then it's going to go, another wavelength, and here, and then here, right? So they're actually always going to be in phase. This is going to lag behind by 2 wavelengths every time. So always constructive interference. What if we look at this one here, along this line right here? Well, if you notice right here and right here and right here and right here and right here, all those spots you have the crests meeting, right? So green and blue meet. That means they're crests, right? They all meet there. How about right here, 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 here, and here. And all of those spots, right? The crests meeting together. Now, it's kind of interesting to see right here in the middle. How about right here, right? This travels a full wavelength. This travels a full wave, constructive interference. How about from here to here, right? That's 1.5 wavelengths, and this is a half a wavelength. So you have constructive interference, constructive, and so on, right? So yeah, hopefully you're getting a good feel for that, and it's not too difficult once you think through it and process what's going on.